Hello, everybody. I'm Mike Moses, President of Virgin Galactic, and I want to welcome you all to our second live space chat.
3, 2, 1, release, release, release. Fire, fire.
On our first episode last week, Beth, our chief astronaut instructor, talked to you about her flight to space. I hope you enjoyed her describe that truly amazing experience. Now, I was wondering if any of you can remember just a few of the flight statistics she gave us. If you think you can answer these next few questions, please type them into the chat, and I'll give you the answers at the end. The first question: how fast did Beth travel as she rocketed into space? And second, how many G-forces, the forces of gravity, did Beth experience as the spaceship accelerated? And finally, how do astronauts wash their hands? Good luck with those questions. Now, before we jump in, I should probably tell you a little bit about my to watch space shuttle launches. After college, I was very fortunate to find myself working for NASA, where I spent 16 amazing years on the space shuttle program. I started out in Houston, Texas in mission control. I then was selected to be a flight director in charge of running shuttle missions, and finally moved to the Kennedy Space Center in Florida, where I was responsible for all the preparations and launches of the shuttle missions. After the shuttle retired in 2011, I joined Virgin Galactic, and here I am today, supporting the teams getting us ready to fly private passengers into space. Now, let's get on with today's space chat. How to design a spaceship. I'm going to tell you all about some of the challenges of designing a vehicle that is made to take people like you and me to space and back regularly and safely. And I'll show you how a few of those challenges were met in the design of our very own spaceship, VSS Unity. Then I'm going to go send you away to apply your own creativity by designing your very own spaceship. And of course, all of us here at Virgin Galactic would love to see the results. The instructions for how to do that can be found on the Kids Corner section of our Galactic Unite website, virgingalactic.com. You can find a link to that page in the description box of this video. We encourage you to upload your designs to social media, and don't forget to tag us using the hashtag Science with Virgin Galactic so that we can see them. Now, spaceflight isn't easy, and human spaceflight is even harder. It takes a lot of people with really great ideas and a lot of patience to make something like this possible. Now, maybe at first glance, designing a spaceship doesn't seem that hard. After all, you just need to pretty much go straight up until you leave the thin atmosphere which surrounds our planet. And when you're done, you just need to come back down and land safely. That's it. All there is to it, right? Doesn't sound so hard, does it? The trouble is, getting to space requires a lot of energy. You need to get going really fast. And then you need to get rid of all that energy as you come back to the Earth. It's really important as you design a vehicle to keep those risks in mind, particularly when you have people on board. As a spaceship designer, you need to look at how you make each stage of the flight safer by design, and then combine all of your best ideas into a single spaceship. After all, it's not much use if you come up with the perfect design for safe and reliable launch if that same design leads to an unsafe and unreliable landing. Now, all of us in the space industry are very keen that smart kids like you go and do their very best at school, so that when you're older, you can come help all of us make better and better spaceships in the future. Okay, now let's look at two ways that our spaceship, VSS Unity, was designed in very clever and elegant ways to make our flights to space as safe and reliable as possible. And along the way, you might notice that sometimes brilliant design is not really that complicated. It's about thinking a little bit out of the box, a little bit differently than other people and what has been done in the past, and come up with a design that makes other people look and say, huh, now why didn't I think of that? First example, launching our spaceship. If I asked you all to imagine what a spaceship launch looked like, I bet you immediately think of something like this. Now, most spaceships have been launched this way over the past 60 years. And although launching from the ground is a great idea, the folks that designed our spaceship realized that it could be done a little bit differently to meet our specific mission. As I mentioned at the beginning, launching a spaceship requires a lot of energy if you're going all the way to space. And if you launch from the ground, you need to put in all that energy starting from rest on the launch pad as you continue upwards. One issue is that down low in the atmosphere, the air is very thick or dense, and therefore creates the most friction or resistance and drag, which means you need even more energy, not only to get to space, but to overcome the air resistance starting from the ground. Now, let me try to illustrate this for you. I'm at home right now, like the rest of you, so I'm going to use some simple Lego to make a simple rocket. So here's my spaceship. Now, let's go add some fuel in order to get us up to space. So this gives us the energy we need to accelerate straight upwards. Now that's great, except the fuel tanks we just added make the whole thing just a little bit heavier. So we really need to add a little bit more energy to get the whole thing off the ground. And that makes us even heavier. So maybe just a little bit more. And you get to the point where you get the final answer. And eventually you can see that the size of our rocket with all the fuel is a whole lot bigger than the size of our spaceship. The designers of our ship wanted to try and make launch as safe as possible for the people inside, as well as making it extremely energy efficient. So here's a question for all of you. Is there any invention you can think of which can climb through the thick atmosphere down close to the Earth's surface and then travel up into the thinner air up above the clouds? And to do this time and time again in an extremely safe manner? Yep, I'm pretty sure I can hear everyone shouting out, it's an airplane. That's correct. Now don't forget, sometimes the best design ideas really can be the simplest. So rather than launch our spaceship vertically from the ground, we use a concept called air launch.
3, 2, 1, release.
We attach our spaceship to a specially designed aircraft, a mothership. We named ours VMS Eve. Now, if you're going to have a mothership, you better name it after your mother. And Richard Branson's mom is a wonderful woman named Eve. We fly the mothership all the way up to 45,000 feet, which is higher than you've ever flown even in a commercial airliner. Up here, the air is nice and thin. That means our launch is very safe and that we need much less fuel in the spaceship to go the rest of the way into space. So that's the way our spaceship design was tailored to meet the challenge of launch. Now, let's look at the challenge of reentry, coming back into the Earth's atmosphere. I'm guessing that there's hardly any of you out there who hasn't jumped into a swimming pool. Some of you might have even dived from high boards or off cliffs into the ocean. And if you've done any of those things, you know that the water slows you down pretty quickly. And then if you don't get it right, it can hurt a bit or even a lot. The trick is to pick the right shape and the right angle as you hit the water. Now that's exactly the same with coming back from space, except that you're hitting the air, the atmosphere, rather than the water. A spaceship is traveling very fast as it comes back to the Earth. And just like hitting the water, you need to have your spaceship in the right shape and coming in at the right angle to get rid of all that energy in order to have a successful reentry. The way that our spaceship does this involves a unique and brilliant bit of design thinking. The inspiration was one of these. This is a badminton birdie, or a shuttlecock, and it behaves in a very interesting way. If you have one of these at home, I want you to try this sometime. Throw the birdie up as high as you can, and then watch it very carefully. What you see is that regardless of how many times you try it, the birdie will always come down with the cone-shaped nose leading the way. It won't spin, and it won't come down the other way around like this. The second thing you'll notice is that it comes down much slower than a ball thrown into the air in the same way. The feathers, these parts here, produce aerodynamic drag. They're like air brakes, slowing the fall and keeping the birdie nice and stable. So if it works for a birdie, why not use it on a spaceship? And that's exactly what our spaceship does. Now, I'm sure some of you are thinking, yes, but how on earth do you make a spaceship into a badminton birdie? Well, here's a quick video to show you how we do that. You can see here our spaceship Unity in her feathered configuration, with the wings, we call them feather booms, swiveled upwards to about 60 degrees compared to the rest of the vehicle. Once we get into space, the pilots raise the feather to put Unity into this configuration before reentry. I've got a model of it here to show you the feather sticking straight up. As the spaceship returns to Earth and meets the atmosphere, this shape will ensure that it automatically turns the right way up and will remain in that position, belly first, with reentry slowed very powerfully by the feathers, which create a lot of atmospheric drag, just like on a badminton birdie. The best part is we don't need any complicated computers or controls to keep a safe reentry angle. The shape of the spaceship and the laws of nature do it all for us. That makes our system extremely reliable and safe for those inside, something that is very important when we go to space regularly. Once we're back down in the atmosphere, the pilots will lower the feather, and our ship returns looking like an airplane, gliding back to a safe and smooth landing on the runway. All right, we're getting towards the end of our time, and I want to save a few minutes to answer some questions. So if you haven't had a chance yet, please enter your question into the chat window. I hope this space chat has given you a little more insight into the fascinating challenges involved in designing a spaceship. And maybe we've also inspired you a little bit, having heard about how our own spaceship meets those challenges. So maybe you'll have a go at it yourself. Take a crack at designing your own spacecraft with what you can find around the house this week. We'd love to see what you come up with. So again, be sure to share it on social media and use the hashtag #ScienceWithVirginGalactic. By the way, a spaceship not only has to be safe and efficient, but it better look great too. So make sure you include that in your design. Our spaceship is partly silver, like a mirror, and it looks awesome if I do say so myself. The secret is we actually made it like that to solve yet another design challenge of spaceflight. Think about that and see if you can figure out why we made the ship silver. We'll give you the answer next week. All right, on to the questions in chat. First question from David: why is a landing skid and not a wheel at the front? That's a great question, David. When the spaceship lands, it doesn't have an engine. It has to be towed off the runway. So we use a nose skid instead of a wheel because we have to go get it with a tow truck anyway. And that nose skid can act like a brake, helping slow the spaceship down as it comes back on the runway. The X-15 NASA aircraft, research aircraft, did the same thing. They used skids instead of landing gear. Great question. Next question is Izzy in San Francisco. How much does the spaceship weigh? The spaceship weighs about 30,000 pounds, including the ship, all the fuel and propellant needed to get the rocket motor to work, and the people on board. So it's pretty lightweight. Again, one of our design principles using air launch, let our spaceship be as light as possible. Helps it manage its energy a whole lot more. Next question, Nikki, 9 years old from Manchester over in England. Does the spaceship get cold in space? That's a great question. Yes, it does. It gets very cold in space. It can also get very hot in space if you stay there for a while. With no atmosphere to absorb the heat from the sun, the side facing the sun gets very hot, the side away from the sun gets very cold. Fortunately, our spaceship's designed to handle that, and it doesn't stay there all that long, so it's not a problem for us. Next question is Gabriella from Madrid. What's your favorite part of the spaceship design? All right, well, I'll tell you, I studied rocket propulsion back in college, so my favorite part is the big rocket motor in the back. Beth did a great job last week of telling you what the view from space was like and what zero gravity floating about the cabin was. But I'll tell you, for me, it's riding the rocket to get there in the first place. That's probably the best part of the spaceship in my view. Fantastic question, thanks. All right, thanks to everybody who submitted those questions in social media. We really appreciate it. Now let's go to the answers from Beth's questions that I asked you at the beginning. It looks like in the chat, quite a bit of you were listening and you got the answers right. Question 1, how fast did Beth travel on her way to space? The answer is about 3 times the speed of sound, more than 2,000 miles per hour. Question 2, what G-forces did Beth pull as her spaceship accelerated? That answer is about 3G, meaning she weighed 3 times more than she normally does while the rocket motor was firing. And the last question, how do astronauts wash their hand? Well, that's the fun one. They wash for 20 seconds, just like you're supposed to, but counting down while they do it, all the way until they get to 3, 2, 1, release, release, release. Thank you all for joining our space chat today, and we hope to see you next week, same time, same place, where we'll be learning about how you actually build a spaceship. Now go get started on designing your own, and again, we can't wait to see what you come up with. If you need any more inspiration, stay tuned for a short video of our spaceship Unity in action. Thanks again, be safe, and be well. Goodbye, everybody.
Wow. Yeah, wow. There's no word for those.
Look out back, man. 1 minute 15. You is incredible. Welcome to the club, astronaut.
Thanks, Space.
I like this club.